All right, welcome back to Robbie's Office Hours. I want to make a plea to you guys right now, okay? These are office hours. Ask me questions. Put them in the comments. Like, subscribe, do all the things, okay? But ask me questions if you don't understand this material, okay? So I've got these letters on the board that clearly mean nothing. SOH, TOA, what the heck does that mean? Well, it's about trigonometry, okay? Trigonometry is kind of like, I don't know, it's like, it's that topic that nobody really likes, okay? They struggle with it, doesn't make sense. You've got angles, you've got functions, you've got trig, you've got triangles, you've got all sorts of geometry running around. It's kind of crazy and chaotic. Let's start with the basics with SOH, TOA, okay? What is it? Where does it come from? All of that. Trigonometry ultimately stems from looking at angles and lengths, okay? In particular, it's looking at geometry. Now, if you give me an angle, which I'm going to denote by the Greek letter theta, right? Then once you fix theta, okay, you get to choose, you can designate names for the other sides of the triangle. So for example, once I fix theta to be this, directly across from that is what's called the opposite, okay? That's the opposite side from the angle theta. It's the opposite leg of the triangle, opposite of theta. Associated to the side down here, this is the adjacent, okay? And then the one that's always opposite 90 degrees is called the hypotenuse. Okay? So all SOH, TOA is it's just kind of an acronym, if you will, of remembering what do sine, cosine, and tangent represent in terms of trigonometry. Okay? So if I look at the sine versus the cosine versus the tangent, okay? So those are kind of the three fundamental trig functions. They have three other kind of doppelgangers, if you will, with secant, cosecant, and cotangent. We'll get into that in just a second. But how are these correspondingly defined? Okay. Well, sine is denoted sin of the angle theta, whatever that is. Okay. So in this case, I've just denoted it theta. So sine of theta, this is equal to the opposite over the hypotenuse. Okay. Hence, SOH. I've got the sine S is the opposite O over the hypotenuse H. That's where that's coming from. Okay. The cosine, so COS of theta, that's equal to, well, C is the A, well, which one of these starts with A? That's adjacent. And then that's H, that's probably the hypotenuse, and that's exactly what it is. So cosine is the adjacent over the hypotenuse. Okay? And then the tangent, so that's this one. Tangent is the O over the A, so what is that? The O is going to be the opposite, the A is the adjacent. So tangent of theta is equal to the O opposite over the A adjacent. Okay? And that's all they are. So if you happen to know what the sides are, so for example, a standard triangle is a 3, 4, 5 triangle, okay, where those are the ratios of the sides. They have to satisfy the Pythagorean theorem, which I'll link that video later. But the Pythagorean theorem tells you that the side of this squared plus that squared is equal to that squared. So 9 plus 16 is 25. Okay? So if I called this angle theta, then I would say, what is the sine of theta? Well, then the sine of theta here would be the opposite over the hypotenuse, so 4 divided by 5. The cosine would be the adjacent over the hypotenuse, so 3 divided by 5, and the tangent would be the opposite over the adjacent, so 4 divided by 3. Okay? But there's three other ones associated to this, okay? It's the reciprocals of these guys. So if I take the sine and I take 1 divided by sine, that's cosecant of theta. This is 1 over the sine of theta, okay? If I take 1 over the cosine, that's going to give me the secant of theta, so that's 1 over cosine. And if I take 1 over tangent, that's cotangent, so that's going to be 1 over the tangent of theta, okay? So that's what these things are. So this one is the cosecant, this one is the secant, and this one is the cotangent. Okay? That's what they are. So if I say what is 1 divided by sine, well, that's really just take sine and flip it. So that's going to be the hypotenuse over the opposite. So that'll be hypotenuse over the opposite. Right? How do I do 1 divided by a fraction? I take the lower fraction, I take its reciprocal, i.e. flip it, and then I just multiply by the numerator. Same thing here. Cosine was adjacent over hypotenuse, so the flip of that will be hypotenuse over adjacent. And tangent was opposite over adjacent, so 1 over tangent, we'll just flip it, so that'll be adjacent over hypotenuse. Adjacent over opposite. Adjacent over opposite. Okay? So if I wanted to use this as my example, okay, if this is my example for 3, 4, 5, then I say, what is the sine of theta? Well, I go over here and I say, okay, the sine of theta, I find theta, I go to the opposite, that's 4, and I divide by the hypotenuse, which is 5. Done. Okay? Cosine is the adjacent, so adjacent is 3 over the hypotenuse, so this is 3/5. Done. The tangent is the opposite 4 over the adjacent, so that's 4 over 3. Okay? Notice that if you do the math, 4 divided by 5, all divided by 3 divided by 5, I get 4 divided by 3, so there's something there. And we'll discuss that in kind of like an identities side of thing in terms of sine, cosine, and tangent and how these trigonometric identities show up. Okay, what about this one? So hypotenuse over opposite. So cosecant is what? 1 over the sine. I don't memorize them as hypotenuse over opposite, hypotenuse over adjacent. I memorize them as 1 over sine. So if I know sine, which is 4/5, then I just flip it and that gives me cosecant. So this should be 5 over 4. Secant is 1 over cosine. Cosine was 3/5, so this is 5/3. And cotangent is 1 over tangent, and tangent was 4/3, so it's going to be 3/4. Okay? So there you have it. There are the 3 trigonometric functions. Sine, SOH, CAH, TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And there are 3 doppelgangers, which is 1 over sine, 1 over cosine, 1 over tangent. Now, before I go, one thing to remember is, how do I remember that cosecant is 1 over the sine? This is the dumbest way to remember it, in my personal opinion, but it works, okay? Is look, I know that cosecant and secant are either 1 over cosine or 1 over sine, and the question is, well, which is which? Cosecant starts with c, so it's going to be, cosecant's definition is 1 over the thing that doesn't start with c. Okay, so cosecant is 1 over the thing that doesn't start with c, 1 over sine. Secant starts with s, so it's going to be 1 over the thing that doesn't start with s, 1 over cosine. I know it's ridiculous, but surprisingly, it works. All right, so I hope that helps you with the introduction to SOH, TOA. And again, like, subscribe, ask me questions. These are office hours, for goodness sakes. Post comments, ask me questions, and we'll keep going.